Alright, let's take a look at our next example. We're going to convert 153,007 to scientific notation. I know that in some countries we don't have this decimal here. Okay, it's just, let's see if I can remove this real quick. It just looks like this, basically with a space. Okay, but for our sake, we do put a comma there to indicate that, basically, like, it illustrates, we put a comma for every 3 digits so we can easily read it better. I know in other countries a comma means a decimal, so it can be kind of confusing. But this is 153,007. So how do we convert this to a decimal? Well, first of all, where's the decimal? Okay, and I'll just remove this comma for right now so it makes it a little bit more clear. But here we go. Where's the decimal point at? You know, we don't really see one. 153,007. Well, we'll talk about that as we go through these steps. So the first step is to figure out where that point is. Well, anytime you have a number and there's no decimal visible, you just stick it on the end of the number, all the way to the right. That's all you have to do, okay? So our decimal point's going to go right there. So let's go ahead and just put one there. I'll make it this color. There's our decimal point. Alright. Easy enough. Just stick it on the end of the number, basically on the right. Next step is going to be to locate the first non-zero digit. Okay, so whatever number occurs first that's not a zero, reading from left to right, that's what we're locating. We can easily see it's going to just be the first number, 1, right? 1's not a zero, so we'll go ahead and underline that. That's our first non-zero digit. Okay, next we're going to move the decimal point to this digit, just like we did before. Okay, and again we're going to move it just to the right of this digit. Okay, just to the right of our first non-zero digit, we're going to be moving our decimal point. So again, let's draw some arrows here. Here's our decimal point. We're going to go 1, 2, 3, 4. It will take 5 to the left. Okay, and I'll even write that, 5 left, in order to move our decimal point to the right of our first non-zero digit. And so, like the previous example, we know that since we move to the left, it's going to, our exponent's going to be opposite of what we might think. We think it's negative, but in fact the exponent is going to be positive 5. So again, if you move to the left, the exponent is positive 5. If you move to the right, it's negative. If we were to move to the right 5, it would be negative 5. So left positive, right negative. That's going to be our exponent. Alright, and then the final step is just to write this in scientific notation. We can see now where our new decimal place is. It is right here. So you might be thinking, you know, can I just write 1.53 and then forget this? Well, it depends on, like, if you want to round to 3 decimal places, then it would just be 1.53. I'm going to go ahead and keep these for this example because this 7 is significant, so you have to include all of these digits. So I'm going to first write 1.53007, and because we moved the decimal 5 units to the left, our exponent was positive 5, therefore our final answer is times 10 to the 5th. Now I really didn't talk about this too much for the last example, but why is it the opposite? Well, if you notice, if you convert this back, what you would basically do, convert this number back to look like that, you would simply just move this decimal 5 units to the right. It tells you that it's a 5, so when you're converting back, you know, you go the way you would think. You would move 5 to the right. So it would be 1, 2, 3, 5, and then you'd have 153,007. So this is why we go the opposite way, because we're converting the other way, right? We're not going from scientific to decimal, we're going backwards. That way, if we were to convert it back, we would see that we would take this decimal, move it 5 to the right. So that's the reason. So that's it for example 2. This is our final answer, and if you have any other questions about this example, let me know.